Hi everyone, welcome to the session. I am Subrahmanya R Sharma, Department of Civil Engineering, SDM Institute of Technology, Ujire. In today's session, we will discuss regarding resolution and composition of forces. And before discussing about resolution and composition of forces, we will see what we mean by force and what are the characteristics of a force. Okay, to define the force is an external agency which tries to change the state of rest or state of uniform motion of a body, and the SI unit, System International Unit of Force, is Newton. In dealing with the civil engineering aspects, okay, everything, if you take a structure and if you divide the structure into elements such as a beam, slab, column and a foundation, everywhere we will deal with the force. In the language of force only, every calculations and every analysis will be done. So, to define a force completely, we require the following elements, and before that we can see some of the forces such as pull and a push. And if you take a structure, usually structure or structural element such as a beam or a column or a slab, usually the structure subjected to these many forces such as compression, a tension or a bending or torsion or a shear. And if we while doing the analysis, if you are safe with these forces, then the structure is said to be safe. Now, to define the forces completely, we need following characteristics of a force and also are called as elements of force. What are those? We will discuss. So, here I have a body. On that body, a force of 10 Newton is acting. Now, to define it, first one, the magnitude. Magnitude is nothing but the amount of force acting on this particular body. In this example, 10 Newton represents the magnitude. And second one, the point of application of force. So, here the point A, in this example point A is point of application of force. Line of action of force, the line along which the force acts. Here the line AB represents line of action of force. Next one is direction. Direction tells which direction force acts. It may be upward, downward, leftward or rightward. In this example, the force is acting from left to rightward direction. Now, we will come to resolution of force. What exactly the resolution of force is? The definition to define resolution of force is nothing but the process of splitting the force into horizontal and vertical component is known as resolution of force. To make you to understand, we will have one small example. A person is throwing a ball in vertical direction and it receives in another end. The ball moves both in vertical as well as horizontal direction, as you can see from here, and the ball is thrown with some angle to horizontal axis. So, we can see here in this motion, so called projectile motion, it is having combined effect of horizontal as well as vertical motion. Now, mathematically to deal with that, consider a body. Okay, on that body I am going to consider a point O, and a force F is acting on that particular body, and which makes an angle theta with respect to horizontal or x axis, and we have vertical axis y axis. Now, to resolve this force in x and y direction, okay, I am going to form a rectangle, so called OF, and this Fx is my triangle. In this particular triangle, and this is my force Fy and Fx, I will define what is Fy and Fx. So, in this right angle triangle, cos theta is nothing but adjacent side divided by hypotenuse, that is f of x divided by f. That is, from this equation Fx equal to f cos theta. Similarly, sin theta equal to opposite side, that is, this is my Fy divided by hypotenuse, that is Fy divided by f, Fy equal to f sin theta. In simple way, the horizontal component of force is f cos theta if theta is given with respect to horizontal axis. Similarly, the vertical component or Fy is nothing but f sin theta. Now, we will see one more process, so called composition of force. I can tell this is the reverse process of resolution of forces. So, the composition of forces is the process of combining the number of forces into a single force such that the net effect produced by a single force is equal to algebraic sum of effect produced by individual forces. Again, I will take an example. I have a body. On that body, I am going to consider a point O. On that point O, I have 3 forces are acting on that. Okay, F1, F2 and F3. Which makes an angle, F1 force makes an angle theta 1 with respect to horizontal axis. Similarly, theta 2 and theta 3 are the angle made by F2 and F3 force. Now, first to find composition or to find resultant of forces, we need to resolve this into 3 component, that is F1x, F2x, F3x. F1x is nothing but F1 cos theta 1 as we done in the resolution of forces. Same method I am going to follow here. So, F2x component of F2 force in x direction or horizontal direction F2 cos theta 2. Similarly, third force F3x equal to F3 cos theta 3. In the same way, I need to resolve the forces in y direction also. F1y equal to F1 sin theta 1, F2 sin theta 2, F3 y is nothing but F3 sin theta 3. Now, once after resolving these forces, I am going to add only the forces which are in x direction, that is F1 cos theta 1, F2 cos theta 2, F3 cos theta 3. While adding these forces, we should take care force is a vector quantity, so it should be added vectorically, which means sign convention need to be considered. Since in this example, all the forces falls in the first quadrant, all will become the positive. Okay. In next session, we'll one more thing we'll do regarding solving a problem on this particular topic. So, Fx equal to F1 cos theta 1 plus F2 cos theta 2 plus F3 cos theta 3. I have added all the forces in x direction. Similarly, Fy equal to F1 sin theta 1, F2 sin theta 2, F3 sin theta 3. Now, to find resultant of that, resultant R equal to square root of f of x whole square plus square root of f of y whole square, and if you take the square root of that, we will get resultant. Thank you. In the next session, we will discuss regarding a problem on this particular resolution and composition of force and to find the resultant of forces.